All right, guys. This one right here picked up on another video, guys. So let's go ahead and dig right in. Right here, guys, we got a power to a power. All right, remember this is x to the first, okay? So you have x to the first to the sixth, y cubed to the sixth. When you have a power to a power, make sure you multiply those exponents. So you end up with log base 9 of x to the sixth. All right, power to a power, you multiply 1 times 6 is 6. And y to the 18. All right, y to the 18. Now, because this is multiplication right here, I'm going to add those, all right, when I expand, because we are expanding, guys. All right, you end up with, let's do another color, log base 9 of x to the 6 plus log base 9 of y to the 18. Okay? Now, the last thing I want you to remember is, see these exponents? Where do they go? Out front. All right, that 18 needs to go out front. So we get log, you get 6 log base 9 of x plus 18 y, not y, 18 log base 9 of y. All right. Final answer right here. Okay. All right. Let's go ahead and look at number 16. All right, we're going to expand this one. All right. We have a power, this to a power. So let's go ahead and simplify that first. That gives us log base 7. And you must do everything, guys. All right, so 5 to the 5th. All right, to the 2nd. All right. So look, 5 to the 5th, guys. Well, actually, you know what? I'm going to leave it like that. All right, I'm going to leave it like that. Here's what I'm going to do. This is going to be 5 to the 10 over, let's just make it 4. Why not? No. Yeah, let's make it 4. All right, we'll do that right there. Okay. Now, because it's division, all right, we're going to subtract. So you end up with log base 5 to the 10th, all right, minus log, forgot base 7. Base 7 to, you know what, I'm going to convert this back to 2 squared. That way we'll just keep the same logic. All right, same logic, because I don't want to expand that all the way out. That would be a really long number. 5 to the 10th, guys, give you 9,765,625. So I don't want to write all that. So now, exponents. Move the exponents out front. Move that exponent out front. All right, minus because of the division. So here we go. Guys, oh, by the way, 2 squared is 4. I just put it back right here. 2 squared. All right, 2 squared. Like I got 5 to the 10th, right? 5 times 2 is 10. Okay. Anyway, put those out front. You get 10 log base 7 of 5 minus 2 log base 7 of 2. All right. So there you go. Number 16. Number 17, solve the problem and check for extraneous cases, okay? So here we go. Right here I have the same base on this side. All right, same base with addition. All right, addition, same base and addition. So I multiply these two right here. That argument and that argument. All right, it's going to give me log base 9. Now remember, this is 8 times this whole parenthesis. So it's 8x minus 10, minus 80. 8x minus 80. And I just said that. 8 times negative 10 is negative 80. Equals log base 9 of 35. Now, same base, but the equal sign. So I can set these arguments equal to each other. All right. So I'm no longer focused on the logs because they're the same thing. So I just look at the arguments now. So now, how do I solve this? Okay. Well, let's add 80 to both sides. Right? So 3 plus 8 is 11. So what does that give us? Oh, I said 30. That's 35. Sorry, guys. That's 35. There we go. So 35 plus 80. It's going to give us 115. So you have 8x equals 115. All right. Now, divide by 8 on both sides. And x equals 14.375. All right. 14.375. All right. That's x. Okay. All right. Let's move on over here to number 18. Same logs on both sides, so I just take the arguments, set them equal to each other. X minus 4 equal to 2x plus 12. All right, how do I solve this? Let's go ahead and move the x minus x minus x. So I have negative 4 equals x plus 12, because 2 minus 1 is just 1, guys. Then we're going to subtract 12 on both sides. All right, negative 12 and negative 4 gives us negative 16 equals x. All right. Now, here's a problem. The problem with this x, guys, is, let's say I put negative 16 right here. Negative 16 minus 4 will give us negative 20. Guys, you can't have log of a negative number. All right, you can't have log of a negative number. So, guys, actually, there's no solution. All right, again, you cannot have the log of a negative number. All right, it won't work. All right, matter of fact, here, look. Well, no, it won't work. All right, just remember that rule. All right, negative 16 won't work. Even though I put negative 16 here, you get negative 32. Negative 32 plus 12 is going to give you negative 20. Can't have a negative number, okay? All right, 19. Again, same base, right? So that means I need to, oh, because of the plus 3, I need to multiply, all right? So I end up with log base 6 of 3x squared, because 3 times x squared is 3x squared, and 3 times 10 is 30, and it equals 2. Now, because there's a log over here and no log over here, we can rewrite this, all right, in exponential form. So 6 squared equals 3x squared plus 30. All right, 6 squared is 36. Right, now what we can do is subtract 30 on both sides. 36 minus 30 is 6. Right, now divide by 3. You get 2 equals x squared. And finally, how do we solve this for that square? How do we get rid of that square? We take the square root on both sides. But remember, when you take the square on both sides, you're going to have a plus or minus. So we get right here that cancels. You have x equals plus or minus square root of 2. Okay. Final answer right there. All right. All right, this will work. All right. All right, guys, for this next one, all right, the thing right here is to remember that 4 raised to the log of the same base. All right, this right here cancels out, so that's 5. And we're going to rewrite this to be log base 3 of 3 to the 4th, all right? Because 3 to the 4th, 3 times 3 is 9, 3 times 3 is 9 here. 3 times 3 times 3 times 3, right? That's 9. that's 9, and 9 times 9 is 81. So 3 to the 4th is 81. But anyway, log base 3 of 3, that cancels, guys, so you're left with 4, and that's going to be 1. All right, the answer there is 1, okay? All right, for this next one, guys, notice that there's a log over here, no log over here, so I need to rewrite this in exponential form. All right, so remember log of bay. All right, this is bay, B, A, E. All right, so when you rewrite it, you're going to get 8 cubed equals 5x minus 4, okay? All right, remember this is the whole argument, all right, because of the parentheses. Anyway, 8 cubed, guys, when you do 8 cubed, you get 512. So this side right here is 512 equals 5x minus 4, okay? We're going to add 4 over. All right, so plus 4 on both sides. So 512 plus 4 is 516. Right? Then we'll just divide by 5 on both sides. All right, that cancels, and you get x equals 103.2. All right, 103.2. All right, right here, same type situation. All right, we have log over here, but no log here. So we're going to end up with 5 to the first equals 2x plus 4. All right, well, 5 to the first is 5, so 5 equals 2x plus 4. Now, subtract 4, all right, so minus 4, minus 4, so you got 1 equals 2x, divide by 2 on both sides, and you left with x equals 1/2, all right. All right, 23. Solving this side, we have same situation. All right, we're going to rewrite it. 2 cubed equals x plus 4. Well, 2 cubed is 8. All right, and we subtract 4 on both sides, and x equals 4. All right, for this one, all right, this is a good one, guys. Check this out. We need to rewrite this as a log because there's no way I can get the same base with 5 and 2. So if I rewrite this, remember the log base 5 of 2 equals x plus 2. All right. Now, guys, we can solve this left side of the equation, all right, by putting it in our calculator. All right, like so. Log of 2, there we go, divided by log of 5. And that gives us 0.43, so we'll go 0.43. All right. Now, one last step, subtract 2. So 0.43 minus 2 gives us x equals negative 1.57. All right, negative 1.57. All right, 25. We're almost there, guys. 25 for this one here. You have a situation to where, let's see. First, I need to move the 5 back here. All right, so I have ln of 2x plus 3 equals ln of 6 to the 5th. All right, next, we need to see how there's ln here and ln here. So since the natural logs are the same, we just take the arguments and set them equal to each other. Okay, 6 to the 5th. Now, we solve this right here. 2x plus 3 equals 6 to the 5th, guys, is going to be 7,776. Subtract 3. 2x equals 7,773. And then divide by 2. And x equals 3,886.5. All right. Okay, that's that one. All right, over here. All right, right here. All right, right here. See how this is the exponent? All right, log. Not log. 4e to the x plus 4 minus 9 equals negative 5. We're going to go ahead and move the 9. So plus 9 on both sides. So you have 4e to the x plus 4 equals 4, right? Then we're going to divide by 4 on both sides. So e to the x plus 4 equals 1. All right. Then to get rid of this e, guys, all right, if you remember from class, to get rid of the e, you just do ln on both sides. All right. So that cancels. I have x plus 4. All right. Equals ln of 1. All right, then you subtract 4 on both sides. All right, so when you do that, ln of 1 is 0. So you have 0. Well, here we'll just do this. X equals negative 4. All right, that's 0. ln of 1 is 0. Minus 4 is negative 4. And last problem. Number 27. The first step here is we need to get rid of this ln. How do you get rid of the ln? We're going to do e on both sides. E over here. So what happens over here? It cancels. How we going? It's 4x plus 6. And it equals, remember the 8 now is an exponent. So e to the 8. All right. Now, we can actually solve this, okay? E to the 8, guys, gives you 2,980.958. All right. Now we just solve it. So if I subtract 6 on both sides, I get 2,974.958. All right. And then we can divide by 4. The whole thing by 4. And when you divide that, you get 743.74. And that's it, people. All right, hope this helps. Sorry I ran so long. I just didn't want to make another video for the last few problems, okay? Good luck. Happy studying.